Hello, welcome to exploring Pandas DataFrame, and I am Jay Kumar from goguru.com. We are trying to see how we can use Pandas to manipulate our data, and this is our agenda for today. We're going to cover what is a data frame, how to load a CSV file into a data frame, how we can visualize the data and run some stats with the data, and then use the different methods within a data frame like iLog, and then the value counts, how we can filter the data, use group by. These are the things that we are going to do today. So with that, let's get started. So what is, to start with, what is Pandas data frame? A data frame is actually a Python object that allows you to use your data just like a database in terms of rows and columns. So what you would do is ideally, you would load your data from, you can actually load it from different sources. It could be a CSV file, or it could be an Excel file, or it could be a list, that Python list, or a dictionary or a map. So there are a number of ways using which you have the data in one source and you load it into a data frame. And once you get it loaded, then you can start using your data as if you're operating on a database table. If you're familiar with the MySQL or Oracle or other things, it is very easy. You can operate it in a similar manner. The syntax is slightly different. We'll look at it, how it works. And the data set, we need something to try out our sample commands, right? So for that, we are going to use the popular Titanic Survivors data set. And this data set is, I'll show you the link where you can download it after the course is over. So it has different fields, like it contains the passenger ID, the passenger name, sex, age, and then there is a survived column, which has a 0 and 1. The 0 says, unfortunately, the passenger did not survive, and 1 says the passenger survived. And then there is age, and then there is a ticket number, and then the fare details. So we'll not be using every single field for all different operations, but we'll be running through a majority of them to see how we can manipulate integer data, float data, string data, and things like that. And the assumptions for this course that we are going to make is, we are not going to write a lot of code programs. I mean, like Python programs. We're going to accomplish everything using interactive Python. So that even if you don't have much experience writing Python code, full-fledged code, you can still use all these commands from the command prompt. And later, if you wish to develop your knowledge, you can apply the commands, and all you have to do is put it in a file and save it with a .py extension. That's all. So the assumption is my file, actually the file that we are using for our exercise, is located in this location. It could be a different location for yours. And we are going to use Python version 3.8. So here we get into the course. So what we do is we are invoking Python. As you can see, we're invoking Python from a Windows command prompt. And you need to make sure that in order to invoke this command, your Python binary should be added to your system environment variable path. If it is Unix, it could be path, and it gets automatically executed when you based on your profile. So once you have everything ready, all you have to do is just type in Python, and you will get the version number, what bit of operating system you have, and then it will stop at the 3 prompts. So the 3 prompts are the ones where you can start typing in your commands. Okay. So far what we have done is we have invoked the Python, and we are in the interactive shell, and the shell is ready to accept our commands now. Okay, moving on. So now that we are ready inside the interactive Python mode, all we need to do is we need to load our library, the Pandas library. This will help us issue all the commands that we want from Pandas. And the first command that we are going to do is we're going to say using the Python pandas module, I want to reload my CSV into it. So I am giving my full location with the titanic.csv, and it will read this entire object and replace it inside a data frame. And we are going to call that data frame in a variable called the df for data frame. Okay, so we have loaded our library, and we have the data frame ready to start playing with our data with. So the first command that we are going to try out today is, what is the shape of our data? How does it look like? How many rows does it have? How many columns does it have? So in order to do that, all you have to do is type in simple on your object name df dot shape. It gives you the number of rows and columns. So as we can clearly see, it says we have 891 rows and 12 columns. Okay, so this is what we get with df.shape. But if you're interested in only getting the number of rows, what you can do is you can just type in len for length of the data frame df. So it'll give you 891. So you can do one of the above depending on what your need is. And then if you want to look at how do you look at all the columns in the data set, so you can accomplish it using df.columns. This will tell you all the columns that are contained within, which is like the passenger ID, the survey, plea class, name, sex, everything. Okay, so it also tells you have 12 columns. Okay, let's move on to the next one. This command is used for, that is, how do you get a sample of your data? So to get a sample of your data, all you have to do is you have to invoke the head method on it, on your data frame object. So what head gives you is, by default, it will give you first 5 rows of data. So if you look at it, you will see all the data, and the dot, 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 what Python does is instead of listing every single column, which will make it unreadable, not like a person site, it'll actually display the first 3 columns and the last 3, and the remaining will be like filled up with the dots, just to make your visualization better. That's all. So df.head gives you a sample visualization. Now, if you want to see more data, that is, I want to see the first 10 lines of the data, 25 lines, or 100 lines, all you need to do is in the head, df.head, you have to give the number of rows that you need here. Now I have given 10 for this example and capture the below output. You can give as many as you like. Okay. So the fourth one says, show me the types of data in the data frame, like integer and floats. So if you want to look quickly look at the structure of the data, all you have to do is df.describe. What it tells us, what describe does is, it takes all the numerical and float columns, and it'll give you pretty lot of details, stats on the data, which is like, if you see, it has not included any of the string variables like a name or a ticket or other details, but it has carefully picked out all the integer or float values, and it is giving you a lot of information like count, like how many rows of passenger IDs do we have, what is the mean of that particular column, what is the standard deviation of it, what is the min value, what is the max value, what is the 25th quartile value, what is the 50% quartile value, 75% quartile, things like that. Now, if you look at the count of it, this matches with the number of records that we have. But if you move a little towards your right, and if you look at age, you see where when everything is 891, this is like oddly 714. What this also means is there are some columns, there are some data within age that are empty, which means age does not have value in all the rows. Some of them are empty. So by looking at this information, you can pretty much get a good insight of how your data is distributed, what is the mean value, what values are missing, and all kinds of information. Okay. So this is pretty much what we covered. It says the previous command only includes integers and float, and why age only showed 714 rows. You know what. And then the fifth one is, how do I display a certain range of rows? So instead of displaying, give me the top 10 or like top 20, how do you say, give me the records from 10 through 20? So you have a command for it where in df, you can invoke .ilock, and you can give integer rows, a range of rows, which is this the one before the colon says the starting range, and the one after the colon gives you the ending range. So when I say 10 colon 21, it will not include the 21st. It will be like -1. So it'll give me all the rows starting from number 10 through 21. Okay, it's a pretty neat command. And this is how your output will look like. And since the output is quite big and it'll be difficult to include everything, I have included dots. So this just gives you an idea of how the output will look like. And then sixth one, how do I display the last 10 rows only? So to display the last 10 records, it's even easier. What you have to do is use the same command, but instead of saying 10, you say -10 colon and nothing after the colon. What this command means is, go to the last record and go all the way to the 10th record from the bottom, and from that record all the way till the end of the file, display me everything. That is what this command means. So anytime you give a negative number in the first range, it will go from the bottom and then it will raise 10 records up. And then if you don't have anything after the colon, it means all the way through the end. So that is what you will get. This is what you will see when you invoke the command. So these are the last 10 rows from our dataset, Titanic dataset. Okay, we'll move on to the seventh command. It's so far the commands that we have seen, as you see in the saw in the previous one, it gives you details of all the fields, right? And some of the fields that we are not able to see are included with the 3 dots ellipse, right? So how do I display only certain specific columns that I'm interested in, like looking at every column? So for that, you have some commands with the df.ilock, which tells, now starting with the same command, like for the last 10 rows, only display me the columns that are in the 3rd, 5th, 4th, and 1st positions. Now mind that the column number position starts at 0. So when I say 3, it is actually the 4th column. This is the command, and there are several ways to accomplish the same thing. If you know, if you are not sure about the column names, then you can give the numbers, column numbers. But if you are aware of the column names, then you can use the below command. It says like, it gives the column name directly, like name, age, sex, and survived. And the careful thing that you need to note here is, when typing a command like this, people, what they often mistake is, if you see, you have said you want 10 rows. From the 10 rows, you want only these 4 columns. When you say you want the 4 columns, you have to embed them within these double square brackets. See the double square brackets at the beginning and the end. So you need to make sure that if you give just one bracket, you'll get a key error. It's a friendly key error. So make sure that anytime you want us to list specific columns, then you have to give a double square brackets. And the same thing can also be accomplished using this following command. Okay. And this is the output that we'll get. See, our output is pretty neat this time. We're just looking at focusing on the specific columns that we are interested, instead of looking at every single thing. Okay. How do you get the count of males and females? We have the data set. We know it has 891 rows. Now, if I want to get the proportion of males and females in the data set, what you can do is, here you say df, and you're saying in the df, I want the column sex and you call the value counts function. What value counts does is it takes the column sex and it gets the count of different males and females, and it displays it here. So that is what the value counts is. Anytime, like even if you have a different field and the field with like a 3 or more different classifications, value counts comes in very handy. Okay. And how do you find the total number of survivors? So we need to note that when we initially looked at the spreadsheet that we showed the sample, the survived column was indicated by a 1. 1 means the passenger survived and 0 means the passenger did not survive. So when we want a broader list of all the people who survived and that did not survive, you can say, give me the survived column value counts. So it will say like, okay, these are the people, the 549 people did not survive and 342 people survived. But if you specifically want just the survived count, what you can say is you can give this command where for the data frame, what you're saying is in the data frame, within the data frame, this is a filter which says filter the survived by the value 1, which means I'm telling inside, get me all the people that survived. And then the outer df, what it says is, now for all the people who survived, should I display all the records, all the columns, or specific ones? I'm saying now for this filter that was used inside, using the outer df, I'm just saying give me the survived ones alone. Otherwise, it will start giving you everything. And then you're saying you want a count of it. So the count, now you'll get pretty neat value of just the survived count, because when you use value counts, you're getting both, right? But here you're specifically focusing on the survived ones. 10. How can I find the total number of female survivors? So the command to do that is, so first you need to look at, there are two filters to it. One is you want to look at the survived count, which is the value for survived is 1. And then you have to look at the sex female. So the command that we do is we have df.survived is equal to 1 and df sex is equal to female. And once you have that filter, and then once you get that filter with all the rows, you're saying you specifically want the columns survived, and you get the count of it. This time, instead of value counts, you're just getting a count because you have narrowed it down to the female survived. So you're just getting a count and displaying it here. Okay. 11. How do I find the male female survived count? Using the group by function. So there is a powerful function called group by. So you don't have to depend on value counts every time. The group by, just like your database group by, what it does is, here we are saying from the data set, give me the sex and survived, all the sex and survived fields. And once you get that, what you're saying is you want to group by the results on sex and sum it up. So this will give you the results like, okay, these are the people that survived for sex. This is the male count and the female count grouped by the sex. Okay. And moving on to 12, what is the average age of the female survivors? So when we want the average, that is a function called mean. So we are using our query df survived is equal to 1, getting all the survivors and the female. And this time you extract just the age out of from the filter. You get all the columns, you extract the age, and then you say mean. This function tells this method, the mean call, gives you the mean of all the survived females. And 13, can I get the names of all the names and age of the men who traveled in first class but did not survive, sorted by age? So in order to do that, we need to do a df with the survived is equal to 0, which says they did not survive, and then the sex is male, and you want to list just the name and age, And per the question, you want to also sort them by age. So in order to sort them, there is a method called a sort values, and you invoke that, and the parameter that the sort function accepts is, it says by what column. I'm saying I want it by age. So this gives you an output of all the males that did not survive, order the names and age, and with the uh, rows sorted by age. So this is what you will see. Okay. So if you look at this output, if you see there's where it is first sorting everything, and here this ellipsis tell that it is showing all the other records, and towards the end, if you see, it's also showing the not applicable values, right, which are like the values which have not been recorded. So this also comes along in the data with our query. Now the 14th question, what it does is, if you look at the previous command, it also included the nulls, right, the NA values. So how do I get a result but not the without the null values for age? So in order to do that, what you do is you do the same command, but towards the very end, you're saying in the results, drop all the NA values. So this is pretty neat. You get the results and you drop all the NA values. So now your output looks even nicer. So you'll get the age, everything is sorted by age, plus all the null NA values have been removed. And the 15th command is, we will try is, find the traveling class of passengers that survive the most along with other passengers too. So you're going to look at the P class. There is something called P class, which says what class the passengers survive, like 1 or 2 or 3rd class. So in that, you want to look at what class of passengers survive the most. So in order to do that, what I am doing is, the filter that I am doing is, get me all the survived ones, and for the surveyed ones, get me the P class, and I want value counts on it. And inside the value counts, this time I'm saying I want the results sorted, and in the ascending order, I want it as false, which means I want it in the descending order. So if you look at the results, it says for class 1, the passengers who traveled on first class, around 136 of them survived. And from class 3, 119 of them survived, and then class second class, 87 of them survived. And in 16, we are going to see what count of passengers did not have age recorded. So age recorded in the sense, what values are empty in age. That is what we are going to look at. So in order to do that, what you do is you just say df of age, which gives you the age or column. And if you're saying is NA, that is, you're saying if the value is it not applicable. If it is not applicable, list me that. And it'll, when it gives you that, you further say I want the sum of it. So which tells there are 177 records in our data set for which the age is not applicable. Now mind that you can also issue the same, give the same command, but without the .sum. It will list all the ages that are null. So the sum, what it is doing is, it is just counting the number of ages that don't have any value. That is all. Now we are going to finally look at replacing null values with mean. So what this means is, you got a listing and you saw some null values, but you realize that you want to fill them with we're just going to try out, right, different options. We're going to manipulate with the data, and you're wondering, can I do something with the null values? Can I impute it with some value so I can use it for my calculation purposes? You're trying different things, right? So in order to do that, we are going to do it in a couple of steps for easier understanding. First is, I'm taking a look at the what I have decided right now to do is, I want to take all the ages that are not populated, and I want to refill them with my mean of the age, the mean of the age. So what I do is, I first find the mean of age, which says it's like averages age is 29.69. And then what I can do is, now df of age, get me the age, and I'm saying fill NA, fill non-applicable values with df.mean. So this command, all it does is it will take all the age that is not populated or it has NA, and it will replace them with the mean values on that column. So that is what it does. Okay. And now we're going to verify if our previous command did our job. So in order to verify that, what we do is we are saying, get me the age and fill all the non-applicable values with the mean values. And now you're again using your old command like is NA, are there any more non-applicable values here? Get me the sum of it. So it says 0 because this command fill NA with df mean already took care of it, and this is just for our verification purpose. This confirms that all our mean values have been populated. Okay. Now time for your exercise. I have a few, 4 of them for you. That is, calculate the total fare paid by survivors and non-survivors, and then the names of the passengers who paid more than the average fare, and then look at, find out the oldest male and female passengers. And then there is a column that we did not use. It's called embarked column, which has different values in it. You might want to get a count of it and identify if there are any nulls, and see how you plan to replace it. These are some things for you to try out. Okay. And I have included the Titanic dataset for our exercise, along with all the commands that we went through in 2 files. The file dataframe underscore, you can go to the GitHub directly to download it. And the file dataframe underscore command has all the commands that we just saw. And under the directory called dataset, I have added titanic.csv that you can look at, and you can bring it into your interactive Python and try it out. I hope this course was useful for you, and thank you so much. We'll visit you with one more video coming up shortly. I am Jay Kumar from goguru.com. Thank you so much.